Good morning all. Today we are going to handle a small, simple and an important topic, that is open circuit and short circuit test of transformer. In our previous video session we have seen the equivalent circuit of transformer. The performance of a transformer can be analyzed on the basis of the equivalent circuit. The equivalent circuit of a transformer basically consists of four main parameters. Determination of these parameters can be done by using open circuit test and short circuit test. Both these tests are very economical and convenient as they provide us with the required information without actually loading the transformer. We will start with open circuit test. This test is also called as no load test. This test is actually performed to determine the no load losses and no load current, which will further help in finding the values of X0 and R0. This open circuit test can be conducted on either sides of the transformer, but it is usually convenient to conduct it on the low voltage side of the transformer. If you see in this diagram, all the measuring devices, that is the voltmeter, wattmeter and ammeter, all these three are connected at the low voltage side of the transformer, and the high voltage side of the transformer is kept open. Since this test is being performed at the low voltage side, the rating of this measuring instruments required also will be small, and hence they can be easily. As this test is being conducted under no load condition, the current which is being taken from the supply is only 4 to 6% of the rated current, and the power which is being taken from the supply is mainly used to compensate the core loss which will occur in this transformer core. Since this test is being performed under no load condition, there will not be occurring any flow of current through this secondary winding or high voltage side winding, whereas a very small amount of current, which will be around 4 to 6% of the rated full load current, will be flowing through this low voltage side. As the amount of no load current which will be flowing through this low voltage side is very small, the copper losses which will be occurring in this low voltage side can also be considered to be negligibly small. Therefore, we can say that the wattmeter reading mainly represents the core loss which is occurring in this transformer core. In this relation, the values of W, V1 and I0 can be determined from wattmeter reading, voltmeter reading and ammeter readings. In this relation, if all these values are known, we can easily determine the value of this power factor. Cos phi 0 is equal to W divided by V1 I0. We have seen in our equivalent circuit class, once if this power factor value is known, we can easily determine the value of magnetizing component of current and working component of current by using the relation I0 sin phi 0 and I0 cos phi 0. If the values of IW and I nu is known, we can easily determine the value of R0 and X0 by dividing V1 with IW and V1 with I nu. The relations are shown here. That is, from open circuit test or no load test, we will be able to determine the values of R0 and X0 of the equivalent. In this simplified equivalent circuit, the values of R0 and X0 are determined using the open circuit test. Next, we have to find out the values of equivalent circuit resistance and equivalent circuit reactance. These values of R01 and X01 are determined using the short circuit test. This test is also said to be the impedance test. This test is usually conducted on the high voltage side, that is the meters, that is voltmeter, wattmeter and ammeters are connected at the high voltage end, and the low voltage side is short circuited, as you can see in this diagram. It is not necessary that the short circuit test must be conducted on the high voltage side itself, that is this meters must be connected at the high voltage side itself. It can be connected at the low voltage side also, but it is convenient to always conduct this short circuit test at the high voltage side. The reason behind the convenient factor is this short circuit test is always conducted at a rated current. If we see in the high voltage side comparing with that of the low voltage side, the current which will be flowing through the high voltage winding will be quite small. So even though if there is any limitation in the power supply, we can easily perform this test as the current which will be, that is a rated current which will be flowing through the high voltage side, will be quite small. In order to perform this experiment, we will short circuit the low voltage side with a thick conductor. Then gradually we will apply the voltage at the high voltage side until this ammeter gives a reading equal to the rated current of this high voltage side. In this test, the voltage which will be applied here to produce the rated current through this ammeter will be usually 5 to 10% of the rated voltage. So it must be ensured that this short circuit test is being conducted at rated current. So in order to produce this rated current, the voltage which will be provided here, or the voltage which will be applied here, will be a reduced one. That will be usually 5 to 10% of the rated high voltage side voltage. This will be the equivalent circuit of the transformer under short circuit condition. The branch I0 can be easily neglected because comparing with this rated current, the value of I0 is very small. As we have mentioned in the case of open circuit test, the value of I0 will be only 4 to 6% of the rated full load current. In this equivalent circuit, the value of this current is actually the rated full load current. This is further simplified form of the equivalent circuit under short circuit condition. From the wattmeter reading and the ammeter reading, we will be able to identify the value of R01 using this relation. That is, the power which is being taken from the supply is indicated by the wattmeter. As this test is conducted at the rated current condition, the power which is taken from the supply is mainly used to compensate the copper loss which will occur in this machine. The reading of the applied reduced voltage will be given by this voltmeter, and the reading of the rated current will be given by this ammeter, and the power reading will be given by this wattmeter. From the voltmeter reading and the ammeter reading, we can easily determine the value of impedance. That is, from this equivalent circuit, if we know the values of this voltage which is being provided, that is the reduced voltage, and the rated current which will be flowing through this, we can easily identify the value of this impedance by simply dividing them. And we have determined the value of R01 from the wattmeter reading and the ammeter reading. So once if these two values are known, we can easily determine the value of X01 by using this relation. That is the basic relation of impedance. Z is equal to square root of R square plus X square. It is very clear from this short circuit test that the values of R01 and X01 can be easily determined by conducting this short circuit test, whereas the values of R0 and X0 can be easily determined by conducting no load test on this transformer. You must always keep in mind that the no load test or the open circuit test is always conducted at rated voltage. That is, this voltmeter reading will be the rated voltage at the low voltage side, and this open circuit test is always conducted at the low voltage side of the transformer. Whereas coming to the short circuit test, this test is always conducted at the high voltage side of the transformer, and you must always keep in mind that this test is always conducted at the rated current condition. In order to achieve this rated current condition, we will be applying only a reduced voltage here. Now we can easily identify all the equivalent circuit parameters, that is R0, X0, R01 and X01 by conducting OC test and SC test on the transformer. From the OC test, we will obtain the values of R0 and X0, and from the SC test, we can easily identify the values of R01 and X01. Next, from the numerical problems which we have analyzed in the previous video sessions, it's very well known that the transformer ratings are always set to be in kVA. Why these transformer ratings are set to be in kVA? Why not in kilowatt? The answer for that is given here. In the case of a transformer, the copper loss is having dependency on the current, whereas iron loss is having dependency on the voltage. That is, the total transformer loss having dependency on the voltage and ampere, that is volt ampere. And it does not have any dependency on the phase angle between this voltage and current. That is, it is independent of the load power factor. That is, if you are connecting different loads of different power factors here, maintaining same values of current and voltage, then even though different output in power occurs due to different power factor values of the connected load, but the losses remain to be same in all the cases. That is, it is very clear that the losses does not have any dependency on the load power factor term. This is the exact reason why transformer rating is said to be in volt ampere or kilovolt ampere rather than watts or kilowatts. Next, we are going to see a numerical problem associated with the equivalent circuit and OC and SC test of a transformer. The OC test and SC test data are given here. The transformer rating is 200/400 volt 50 Hz single phase transformer. From the data given, it's very clear that the OC test is being conducted at a low voltage side at rated voltage, and this SC test is being conducted at a high voltage side, and this will be the rated current. We can easily determine the values of R0, X0 and R01 and X01 from the data which is given in the question, that is OC and SC test data. You don't have to look into the second part of this problem. You just need to learn how to determine the equivalent circuit parameters from OC and SC test of them. And it also must be ensured that the corresponding equivalent circuit is drawn, because drawing this equivalent circuit itself carries a few marks of the problem. With that, we are completing today's session. This is a very important topic. You will have to perform a lab session also with regard to this OC and SC test of transformer. Thank you.